Integration. We have considered some concepts in our last class, but today we are considering further solve problems or questions. So please take note of all these formulas. We need to write them out. They are from differentiation. If you don't know all these formulas, I bet you may find it very difficult to solve. Okay, the formulas again, you need to pause it and write them out. So this is the last one there. Once again, the last one. Okay, let's consider examples. Now, first example, let's consider integration of the sine cube s over cos square s. So this sine cube s can still be written as sine square s sin s, then over our cos square s ds. Now don't forget that sine square over cos square simply means tan square s. Then this is our sin s still there, ds. Now we need to recall that tan square s from our trig. I don't know if you have idea, but let's recall that tan square s is this, and that's how to do it. So the integration becomes, instead of that tan square s, it will be sec square s minus 1, then sin s ds. If we expand this, we are going to have sec square s sin s minus sin s dx. That is, this times this. Now this thing requires the knowledge of trig identity. This is sec square s. The sec square s is same thing as 1 over cos square s. Then there is sin s here minus sin x dx. This thing can be written as this. I can separate the cos under them. This will be 1 sine over cos times 1 over cos s. Cos square s is cos s minus sin s dx. From that place, you see that this is sec s, sine over cos is tan s, then minus sin s that is there. We are now left with integrating this. When we integrate it, what are we going to have? Let's check from our this thing. Integration of sec s tan s is just sec s. So in that case, this one, the integration of this one will become sec s, and integration of sin s is minus cos, so this will just be plus cos s plus c. So that is just our answer to it. Another way by which you can solve the question is this. After we have written this, I can rewrite it as sin s into, instead of this sin square s, it can become 1 minus cos square s. That is this sin square s divided by this cos square s. Can be written in two forms. Can be cos s over, let's put cos s2 here, so that here will become sine over cos, which is tan x, and for this one 1 over cos is sec s minus cos over this is cos x dx. From that place, if you expand, you are going to have sec s tan x minus tan times cos is just simply sin s ds, which is same thing as this. It will give us the same thing. Now let's consider another example. Integrate 1 over 1 minus cos s. How do we do this? We rationalize. That is, we multiply both sides by the conjugate of denominator. What is conjugate? That is, we multiply both sides by 1 plus cos s over 1 plus cos s. That is how to rationalize. From this place, if you expand, 1 times the numerator will still be the numerator over, if you expand this one, it will give you 1 minus cos square s ds. But we need to recall that 1 minus cos square s, it is simply sine square s, just like what we use here. In that case, this one will become 1 plus cos s over sine square s dx. So from that place, we are going to have, I can put this under this, it will be 1 over sine square s plus cos x over sine square s. That sine square s here, I can write it as sine s times another sine s ds. But 1 over sine square simply means cosec square s plus this one is cot s. 1 over sine is cosec s dx. So what will now be our final answer? We are now dealing with cosec square s and cot s cosec s. You can see, where is cosec square s? This is cosec square s. It gives me minus cot s. And this is cosec s cot s. That will give me minus cosec s. So that means this answer, if I integrate this, I will have minus cot s. I will have minus cot s. If I integrate this, I will have minus cosec s plus c. So that's our final answer. Let's consider this question. If we want to solve this, it looks like the one we just solved. We need to just rationalize it. And how do we rationalize it? We multiply both sides by conjugate of denominator. That is 1 minus sin s over 1 minus sin s. This is 1 plus here. We'll multiply by the conjugate of that denominator. And this will be equal to, this one will simply give me 1 minus sin s all square, because they are the same thing. But if I expand this one, it will give me 1 minus sine squared x. So if I recall from trigonometry identities, I will know that 1 minus sine squared simply means cos square s then dx. So they both have square. In that case, I can write them together. I can write them like this: 1 minus sine x over cos s all squared, because they both have square. And from this place, I can put it under each of the, I can put this under each of the expression in the numerator. That is 1 minus cos s minus sin s over cos s ds. All the square, they're all square. Now 1 over cos simply means sec s minus this sine over cos simply means tan x all square, then dx. Then we need to expand this. So if you expand this one, it will give you sec square s plus tan square s minus 2 sec s tan x dx. This is sec square s plus, don't forget that this one, if I recall, tan square s simply means sec square s minus 1 from trig identity. So this one becomes sec square s minus 1 minus 2 sec s tan x dx. So if you simplify it further, we should have 2 sec square s minus 2 sec s tan x minus 1 dx. Finally, we cannot integrate this. From the table that I showed you the other time, integration, this is integration of sec square s, this is integration of sec s tan x. So in that case, if I apply everything, if I integrate sec square s, I will have tan x. minus. If I integrate sec s tan s, I will have sec s. And if I integrate 1, I will have x, then plus c. So this is our answer. That one, we are considering integration of sine square s, cos square s, and tan square s. We have been dealing with that of tan square s. Let me consider tan square s. Anytime we want to integrate tan square s, we only need to recall that we cannot integrate it directly, but we can use sec. You only need to recall that tan square s is same thing as sec square s minus 1 dx. We have known the integration of sec square s to be tan x, because if I differentiate tan x, I will have sec square s, then minus. If I differentiate integrate 1, I will have x, then plus c. Now for these two, we need to recall what we call half-range formula. We need to recall that sine square s is half into 1 minus cos 2s. Also, we need to recall that cos square s is equal to half into 1 plus cos 2s. So that is how to do that from that place. Let me pick sine square s, then you try cos square s yourself. If I want to integrate this, I only need to recall the formula. This is a formula. Our answer will now be half into 1 minus cos 2s dx. From that place, it will now be easy for me. So if I integrate 1, I will have x minus. If I integrate cos 2s from the formula that we give, we said here, if we integrate cos ks, it will be sin ks over k. So that means if I integrate cos 2s, it will be sin 2s over 2 plus c. So that is our answer. Now, let us now use this idea to solve this question. Let's say we want to integrate sin square s, cos square s dx. Let's assume that we want to integrate this. So we only need to recall this. So anytime we are saying something like this, we only need to recall this formula. So in that case, we are going to have this formula becomes half into 1 minus cos 2s times half into 1 plus cos 2s dx. So this will now be equal to half times half is 1 over 4. Let's bring it out. If I expand these two, these are difference of two squares. This should just be 1 minus cos squared 2x. So here we still apply the half range form because we cannot integrate this. So we still need to apply the half range formula for this one, which we are using this one. Remember that cos 2s becomes half 1 plus cos 2s, cos square s becomes half 1 plus cos 2s. Definitely, if I decide to put 2 here, we know that cos square 2s will have been half into 1 plus cos. This one will become 4x. So in that case, I will use it. So this will be half into 1 plus cos. It will now become 4x. So whatever that is there, you only need to multiply 2 by it. Then dx. This is, if you expand, we have 1 minus half cos 4x dx. So this is 1 over 4 into 1 minus half is half. So we have half cos 4x dx. Since half is common, I can bring it out so that it will become 1 over 8 into 1 minus cos 4x dx. So it's now very easy for me to do. If I integrate 1, I will have x minus. If I integrate cos 4s, I will have sin 4s over 4 dx. So that's the solution to this question. Then we can practice this one. So it's left as an exercise. You only need to apply these formulas for the two. And how do we do that? Let me quickly give a small hint. We know that sine 4s is same thing as sine square s all squared. And we have known what sine square s represents there. So this is half into 1 minus cos 2s all squared. So that will become 1 over 4 into, if you expand this, it will give you, so that will give you 1 minus, let's keep it like this. So similarly for cos 4s, it will also be 1 over 4 into 1 plus cos 2s all squared. Therefore, we want to multiply them together. If you multiply them together, it will be 1 over 16, that is 1 over 4 times 1 over 4, into these two, 1 minus cos 2s squared, 1 plus cos 2s squared. But don't forget that you can apply indices here. They both have square, so you can multiply inside so that we have 1 minus cos squared 2s all squared dx. Then you now need to expand this to get your answer. But at the end of the day, it will still lead to something of this nature. It will still lead to something of this nature. So just take note that sine squared ks is same thing as half into 1 minus cos 2 ks. So similarly, if it is cos squared ks, it will be half into 1 plus cos 2 ks. So at the end of the day, something like that will come out here in order to solve your question. Consider this example. Integrate s times square root of s. Now, what we do is we let us say let y be equal to square root of s plus 1. If you take this square root to the other side, you are going to have s plus 1 is equal to y squared. If you make s zero formula, s will be equal to y squared minus 1. Then we need dx. You are using integration by substitution. If you differentiate this, we have 2y, then dy. Now let us bring it here. Therefore, our integral becomes x. This is our x. That is y squared minus 1 times this one is y times y, then dx. This is our dx, 2y dy. If you expand further, you should have 2y squared into y squared minus 1 dy. So if you expand there, we should have 2y raised to power 4 minus 2y squared dy. So I can now integrate this. So integrating this will give me 2y raised to power 5 over 5 minus 2y raised to power 3 over 3 plus c. We have known what our y means. This is our y. So in that case, our answer is square root of s plus 1 raised to power 5 over 5 minus 2 into square root of s plus 1 raised to power 3 over 3 plus c. So you observe that 2 is common. Also, square root of s plus 1 raised to power 3 is also common. So when we bring it out, it will remain square here. And that square will cancel this square root. So it will remain s plus 1 over 5 minus 1 over 3 left. So which will give me 2 over, the SCM here we know is 15. So let's just say 2 over 15 into square root of s plus 1 cube. And simplifying this further will give me 3s minus 2. So that's the final answer. Question. Let's study it and the solution. This is s to the power 5 s cube. So what we want to do is that we want to find a way so that they will be the same thing. X cubed by 5 has been expressed as x cubed and x squared. At the end of the day, we are going to let our u to be x cubed, or better still, let our u to be this. So we have the solution there. So this is the solution. So you can see. So this is study it. Just take note of this. Integration in terms. This is integration in terms of logarithm function. This type of integral is very common when it comes to integration. So this thing simply means that when you have an integration such that the differentiation is at the numerator while the function is at the denominator, the answer is just ln of that function. For instance, if you consider this cos s over sin s ds, this is the function. You see that differentiation of sin s is cos s is at the numerator. In that case, without stressing myself, my answer is just ln sin s plus c. So that means if I'm now asked to integrate sin s over cos s ds, observe that if you differentiate this, you are going to get minus sin s. If I differentiate cos s, I will get minus sin s, but it is sin s that is there. Since it's sin s that is there, but it is minus that I need in order to use the formula. So you just manipulate, put minus here, then put minus here. So that my answer is this minus, then integration of this one will be ln cos s plus c. So that means if I'm not having something of this nature, 2s minus 3 over s squared minus 3s plus 6 ds, observe that if you differentiate this, you are going to have 2x. If you differentiate minus 3s, you are going to have this. So in that case, since the differentiation is on top, I can call it ln s squared minus 3s plus c. Consider integration of arc sin s, arc cos s, and arc tan s. Now, let's consider the first one, then you do the rest. Anytime you are given arc sin to integrate, or arc cos or arc tan to integrate, how do we do it? Let me put I to be this. The first thing is you let a variable to represent that arc. Let's say I want to use y. Let y be arc sin s. The next thing is you make x the formula. Then if you make x the formula, s will be equal to sin y. After that, you differentiate, you say dx. If I differentiate sin y, I will get cos y, then dy. We cannot go back to this function. So that will be integral sin s, arc sin s. Our arc sin s is y. Then dx. Our dx is cos y dy. So this will later lead to what we call integration by part in our last class. And we have treated something like this in our last class. So integrating this one now, it will give me y sin y plus cos y plus c. That is if we apply integration by part, which we have taught before. Now, what is sin y? Sin y is x, and y is arc sin s. So this thing simply means s arc sin s. Cos y. What is cos y? How do we get cos y? We know that from this place, cos y is simply square root of 1 minus sin square y. We have considered this under differentiation. This is 1 minus sin square y. Our sin y is x, so that will just be 1 minus x squared. So here will be square root of 1 minus x squared plus c. So that is that about that. We can use the same idea to solve for arc cos s. So we use the same idea to solve for arc cos s. But when you solve for arc cos s, so we can similarly get s arc cos s minus square root of 1 minus s squared plus c. And for arc tan s, you do the same thing. But let me show you the solution here. This alternate. I don't need to explain that again. So this is the solution. Now another important integration is integration by trigonometric substitution. Anytime you see a function of this form, 1 minus s squared, we make use of substitution. S is equal to sine theta. If it is 1 plus s squared, we make use of this, and if it is s squared minus 1, we make use of this. And we need to recall that 1 minus sine square theta is cos square theta, 1 plus tan square theta is sec square theta, and sec square theta minus 1 is tan square theta. So we need to recall this. Let's now assume that we want to integrate this. Let's assume that we want to integrate 1 plus s squared, for instance. If I want to integrate 1 plus s squared, what I would do is looking like this. So I would use s is equal to tan theta. After, if you have done this, you just say dx. If you differentiate, ds is equal to sec square theta d theta. If you have done that, you come back to this place. That will be square root of 1 plus s squared. Let me say our I is equal to square root of 1 plus s squared. Our s squared is tan square theta dx. This is our ds. It will be sec square theta d theta. And square root of 1 plus tan square theta. 1 plus tan square theta is sec square theta here. And the square root will just be sec theta. Then sec square theta d theta. So this has led to integration. This has led to another integration. So since we cannot apply integration by substitution here, so we need to apply integration by parts. And how do we do that? Now, our integration by part, we remember, is uv minus integral v du. So let our u be sec theta and let our dv be sec square theta. Remember, we normally find du. If you differentiate sec theta, you should have sec theta tan theta d theta. And a v means I should integrate. If I integrate sec square theta, I will have tan theta. Then our I equal to uv, this times this, that is sec theta tan theta minus integral v du. This is our v, this is our du. So that will give me sec theta times this, that is tan square theta d theta. Our integral becomes sec theta tan theta, sec theta into, this is tan square theta. Don't forget, tan square theta, if I do it, it will give me sec square theta minus 1 d theta. Then our I equal to sec theta tan theta minus, if I expand this, I will have sec cube theta minus sec theta d theta. Our I equal to sec theta tan theta. If I expand this, I will have sec cube theta d theta. This minus times minus become integral of sec theta d theta. Don't forget that this is what we are really integrating. This is it. This is what we are. This is our I. That is sec theta sec square theta. That will be sec cube theta. So in that case, I can write it as I equal to sec theta tan theta minus, this one is our I, the I that we are integrating, plus it will remain ln sec theta. From the formula that I gave you the other time, integration of sec theta is ln, you need to go back there from the beginning, ln sec theta plus tan theta plus c. Now let's bring this one outside. When minus I comes here, it becomes plus I, so that will be 2I equal to whatever that remains there. Then making I desired formula, I will be equal to sec cube theta d theta, that will become sec theta tan theta over 2 plus ln sec theta plus tan theta over 2 plus c. So that's our answer. And also we have even integrated this, and what we have said is that square root of 1 plus s squared ds is equal to sec theta, but this is in form of theta. We need to bring it back in terms of s, because here we have said that let s be tan theta. So if s is tan theta, then sec will just be, we know that 1 plus tan square s is equal to sec square s. So sec will just be square root of 1 plus tan square s. That is square root of 1 plus, our tan is s, so this will be 1 plus s squared. So in that case, our answer here will be x square root of 1 plus s squared over 2 plus ln s plus square root of 1 plus s squared over 2 plus c. So that is our answer. That is the integration. Now if I consider another one, let's say I want to integrate square root of 1 minus s squared dx. Square root of 1 minus s squared dx. So when we have 1 minus s squared, we make the substitution s is equal to sine theta. So let's make the substitution. You will say that let s be equal to sine theta, so that if after that you differentiate, if you differentiate, we have cos theta d theta. You now come back here. Our I will now be square root of 1 minus s squared. Our s is sine theta, so that will be sine square theta. Then our ds, this is our ds, cos theta d theta. So this is simply cos theta d theta, because here we have said 1 minus cos square s is sine square s, and 1 minus sine square s is cos square s. So the whole thing here is cos square s. The square root will cancel, so it will remain cos. So from that place, we are going to have cos square theta d theta. And I've explained how you are going to deal with integration of cos square theta. I said you will have half into 1 plus cos 2 theta d theta, which means if I integrate, I will have, if I integrate this, I will have theta plus, if I integrate this, I will have sine 2 theta over 2 plus c. So don't forget that sine 2 theta is same thing as 2 sine theta cos theta from trigonometry identity. This thing is same thing. From this place, 2 cancel 2. The reason is that we need to write all this theta in terms of s, because this is what is given to us. It is s that is given to us. In that case, our answer will be half into theta. Our theta, if we make theta the Euler formula here, it will be arc sine, because we have said that let s be sine theta. Then this will imply that theta will be arc sine s. So in that case, this theta will just be arc sine s plus sine theta is represented by x here, while cos theta is square root of 1 minus sine square theta, 1 minus s squared, then plus c. So that is the answer. Now let's assume that we now have this square root of 1 plus square root of s squared minus 1 ds. 1 divided by square root of s squared minus 1 ds. So what are we using here? S squared minus 1, we use sec. I will say that let s be sec theta. I will differentiate. ds is, if I differentiate sec s, I will have sec s tan theta d theta. So that our integration becomes 1 over square root of sec square theta minus 1. Our s is sec. Then our ds is sec theta tan theta d theta. Don't forget that we have said sec square theta minus 1 is tan square theta. The square root will cancel tan square. It will remain ordinary tan. Then sec theta tan theta d theta. So that this will cancel this. What we are going to have left is integration of sec theta d theta. And from the tables that I showed you, integration of sec theta will give me ln sec theta plus tan theta plus c. We have known what sec means. Sec is represented by x, but tan is square root of, this is our tan here, square root of x square minus 1. So this is square root of x square minus 1 plus c. So that's our answer. Then you can practice this as well. Square root of 1 minus x squared. So you can practice it. We are now moving to integration by partial fraction. So the concepts will be considered. That is, the formulas that will be useful for us under this integration by partial fraction are follows. The first thing is integration of f prime of s over f of s. We have explained this before. We said this f prime of s over f of s is ln f of s. That is, if a function is at the denominator and the dimension of function is at the numerator, it is this. For instance, if I have something like this, 2s over ln x over 1 plus s squared, you observe that if you differentiate this, you get this. So answer is just ln 1 plus s squared. Also, when we integrate 1 over 1 plus s squared, that is arc tan s. I've given you under standard integral. This one is standard because if I differentiate arc tan s, I'll get 1 over 1 plus s squared. And this is the general form of this. If this one turns to a number, which is a squared, so we can write it as 1 over a arc tan s over a. That's the answer. And this one, if it is linear, 1 over as plus b gives me 1 over a plus ln this plus this. You can see that it is the ln of the denominator, just like what we have here. Also, for the concept of integration of partial fraction, that means you must have been introduced to partial fraction before coming to this, which I expect you have done. So I don't need to stress myself. I will just assume that you have done something of that nature. But if you have not known anything about partial fraction, I will refer you to my YouTube channel. Just go there, type partial fraction, and learn how to do it before coming to integration by partial fraction. If you don't know anything about partial fraction, you may not understand this concept. So we need to know more things about partial fraction. So let's take example. Let's say example 1. We want to integrate. Let's say we want to integrate 2x over 3 plus s into 3 minus x dx. Now this is partial fraction. If you can simplify, we normally use partial fraction if this denominator can be simplified, can be factorized, So we can factorize this. That is when we normally use partial fraction. Though we will have used this formula, but since the denominator can be factorized, that it requires partial fraction. So from this list, I will need to resolve this into partial fraction. Resolve. But I expect you to have known partial fraction. This is, we see a over 3 plus s plus b over 3 minus s. So after finding that, we need to know our a and we need to know our b. So when we do it, we'll see that our a is 1 and our b is our a is minus 1 and our b is 1. I expect you to have known this. But I've said if you don't know anything about partial fraction, go to my YouTube channel and download the concept. So we have this. So that means this integration that is being given to us will be equal to what we have here. Minus 1 over this. That is minus 1 over 3 plus s plus b. Our b is 1 over 3 minus s. So it's as easy as that if you have known partial fraction, because this one looks somehow cumbersome. But with the help of partial fraction, you have expressed it in this format. So the answer is this. In this place is just minus. Since if I differentiate x, I will get 1. So the 1 is on top. So our answer is just minus ln 3 plus s. Also, if I differentiate minus s, this is minus s, I will get minus 1. But minus plus 1 is here. So I can write it as minus. So this is minus ln 3 minus s plus c. But by law of logarithm, we know that minus will turn to plus, and minus will turn to multiplication of the numbers, and plus minus will turn to division, and plus will turn to multiplication. So the answer here is just multiplication of the numbers plus c, because minus times minus is plus, so it has made this place to become multiplication. Let's take another example. We want to integrate this. So we observe that this one can be factorized. In that case, we can apply integration by partial fraction. Now, we will now need to express this one or resolve it into partial fraction. So how do we do that? This denominator can be expressed as s minus 2, s plus 2, and s minus 3, because s squared minus 4 simply means s minus 2 and s plus 2. In that case, I will write the partial fraction as this, which can be written as a over s minus 2 plus b over s plus 2 plus c over s minus 3. So from this place, if you use the partial fraction method that you are going to study or you have studied before, so you are going to get a to be minus 9 over 2, you are going to get b to be 21 over 10, and c to be 37 over 5. So the integration, which is 5s squared minus 6s plus 10 over s squared minus 4 s minus 3 dx, will just be equal to a over this minus 9 over 2 over s minus 2 plus b 21 over 10 over s plus 2 plus c 37 over 5 over s minus 3 dx. Finally, integrating this one, 1 over s minus 2 will give me ln s minus 2. 21 over 10 over this will give you ln s plus 2. And finally, 37 over 5, this will give you ln s minus 3 plus c. So that is that about that's the solution to this integration. With the help of partial fraction, we can be able to integrate this function. Let's take another example. Example 3. We want to integrate this. So our aim is just to express this in partial fraction. When we express it in partial fraction, we are going to have 1 over s minus 1, 2 over s minus 1 plus 1 minus 2s over s squared plus 1 ds. Now, this is what we are going to get by partial fraction. I've expressed this thing as this using partial fraction. Now, I can still continue and write it like this. 2 into s minus 1 plus, this one can become 1 over s squared plus 1 minus, this one is 2x over s squared plus 1 dx. We can put this under each of the numerator. Now, the constant is 2. 1 over s minus 1 is simply ln s minus 1 plus, if I integrate this, which I've given the other time, which I've given here, to give me arctan. So this will give me arctan minus. You observe that if you differentiate s squared plus 1, you are going to get 2s. So since the differentiation is on top, I've told you the answer is just ln of the denominator, then plus c. So that's the solution to this integration. If you consider another example, let's say example, which is this, we want to integrate this. So this is another concept of partial fraction. So if we resolve this into partial fraction, if you resolve it into partial fraction, so we are going to have 4 over 3 over s plus 1 minus 4 over 3 over s minus 2 plus 1 over s minus 2 squared. Let's put the s there because of space. Now, we are not left with integrating this. So this is 4 over 3 ln s plus 1. This 4 over 3 is constant. 1 over this is s plus 1 minus another 4 over 3. 1 over s minus 2 is ln s minus 2. But for this one, you take it as if you are integrating s to the power minus 2. That's what you are going to do. You take this one. Since we call this thing a monic, if I integrate it, you know this is s to the power minus 2. It will be s to the power minus 2 plus 1 over minus 2 plus 1 plus c. So that our answer is 4 over 3 ln s plus 1 minus 4 over 3 ln s minus 2. This will give me minus 1 over s minus 2 plus c. So that will be the answer to the integration. This is example 5. So this will be left as assignment. Practice that one. So let's take note of something. When you are giving integration in terms of rational function like this, that is in terms of division, two things will first come to our mind, or must first come to our mind. The first thing is, can we express it as ln? That is, can the differentiation of the denominator be on top? If the differentiation of the denominator be on top, then we can easily say the answer is ln, or we can express it. For instance, let's say I have something of this nature, 2s plus 3 over s squared plus 3s plus 1. You observe that if you differentiate this one, you get this one. In that, I can quickly say that the answer is ln of this. That is one. Another thing is that, another thing that will come to our mind if that does not work is partial fraction. And we can only apply partial fraction if this thing can be factorized. If it cannot be factorized, we can't use it. And also, we can apply the ln. For example, if you consider something of this nature, 2s minus 1 over s squared plus s plus 3 ds. You observe that, let's say s squared plus 5. You observe that this thing cannot be factorized. Assuming it can be factorized, I quickly use partial fraction. Also, if I differentiate this, I cannot get what is here. In that case, we cannot apply this. So what do we apply? Let's take example for it. This is an example. Observe that if you differentiate s squared, you get 2x is here. If you differentiate 8x, although if you differentiate 17 is 0, so we don't need it. If you differentiate 8x, you get 8, and this is not 8. So in that case, it cannot work. Also, this thing cannot be factorized, so we can't apply the two things that we said it will come to your mind. So what are you going to apply? The first thing is, let us first check. You first check the differentiation of that denominator. That's the first thing. Check the denominator of differentiation of this denominator, and that will give me 2x minus 8. So it is 2x minus 8 that we get here. So in that case, the first thing is, you will express this numerator in terms of 2x minus 8. You know, normally it is 2x plus 3 that we have, but it is 2x minus 8 that we need on top. Just put 2x minus 8. Quickly put your plus 8 so that you will not be biased. Then there is 3 as well, divided by x squared minus 8x plus 17 is equal to dx. Also, you should take note of something. This denominator as well, you need to use what we call completing the square method, which you have been familiar with. We use completing the square method for this. And how do we use completing the square method? We look for the half of coefficient of half of x, that is half of 8, which is 4. We add 4 squared to it. We say minus 4 squared again plus 17. So this one will give me s minus 4 all squared. The remaining one here, this is minus 16 plus 17, that is plus 1. So we need to take note of this one too. Now let me come back to my question. Here will now become 2x minus 8 plus 11 divided by x squared minus 8x plus 17 dx, which we can rewrite as 2x minus 8 over x squared minus 8x plus 17 plus 11 over x squared minus 8x plus 17 dx. So it is now very easy for us here. This is 2x minus 8 over, what I've done here is that I've separated this denominator under this one and under this one. That's what we have here. So that the integration becomes, plus the second one. This second one that is here, it is the result that you get here that you are going to put there. That is 8 square, that is x minus 4 all squared plus 1 squared dx. So that's what we are going to put there. Then if you are putting there, what are we now going to use? We're going to use this thing which says 1 plus x squared is arc tan x. Now the first one is that what you have now said there is differential of this one is here. So the answer is ln x squared minus 8x plus 17 plus 11. The answer, this one is representing 1 plus x squared. Everything is representing our x. So this will be 11 arctan x minus 4 plus c. So that's the solution to this question. Another one, we have example 7. 2s plus 4 over x squared minus 3s plus 13. Now, the two things that will come to our mind is, if I differentiate this, can we get this? Let's try it. If you differentiate x squared, you get 2s. Is here. But if you differentiate minus 4s, you get minus 4. And this is plus 4. So that cannot happen. Another thing that should come to our mind is partial fraction. And if you want to use partial fraction, this one must be factorized. So this one too cannot be factorized. You can check it. Now, in that case, you should now think of what will be the differentiation of the denominator. That will be 2x minus 4. It is 2x minus 4 that should be there, but we have 2x plus 4. In that case, the integration will be equal to 2x. Just put that minus 4 there. Immediately put plus 4 in order not to be biased. Then the remaining 4 that is here. Then over x squared minus 4s plus 13 dx. So you need to work this out too. X squared minus 4s plus 13. What will you have? That should be x squared minus 4s. You look for the half of this coefficient, which is 2 squared. You use completing the square method. Minus 2 squared plus 13. So this, the whole of this 3 will become s minus 2 all squared. But this one, this is minus 4 plus 13, that is 9. So which I can write as 3 squared. From that place, the integration will become 2x minus 4 over s squared minus 4s plus 30 plus the second one 8 over s squared minus 4s plus 30 then dx. So this second one, this is what you are going to put there for the second one, so that we have 2s minus 4 over s squared minus 4s plus 13 plus 8 over, this one will give me s minus 2 squared plus 3 squared dx. So it is not easy for me to do this one. This one will give me ln s squared minus 4s plus 13, because if I differentiate this one, I will get this one, plus 8 is a constant. Then how do we integrate this one? I've shown you the other time. So we'll make use of the formula that I gave you, this one. You make use of this one, which says a square plus s square is 1 over a arctan s over a. Our a is representing 3. Our s is representing this. So it is 1 over a, that is 1 over 3 arctan s minus 2 over 3 plus c. So finally there, our answer is ln s square minus 4s plus 13 plus 8 over 3 arctan s over 2 arctan b. So that is the final answer to this question. So we'll meet in the next class.